So, whom should you date or choose as your life partner? Guys, are you on dating apps like Tinder or Bumble? Or have you ever tried any dating app to find a partner for you? This is one of the most critical decisions of everyone's life. Not only me, even Warren Buffett, the billionaire investor, believes the same. But do you know that machine learning algorithms, NLP, recommendation systems, and many more algorithms are working behind the scenes? Guys, you will be amazed to know that in 2022, around 366 million people worldwide have used dating apps. 14% of the people marry someone they meet on dating app. And in 2021, dating apps revenue was $5.61 billion. Even though Tinder has a free version. Welcome everyone. Some of you have already found a match on dating app while others are still waiting for that special connection. Guys, user interface of these apps looks like simple process of swiping or liking the profiles. But have you ever wondered what's happening behind the scenes? If you are curious to know, you are at the right place. So get ready to uncover the secrets behind how these apps help people to find dates. So how do these dating apps actually work? The first step is profile creation, which is just like your dating resume where you sign up, create a profile with your information like age, location, interest, and then you start browsing the profiles of other people. Now behind the scenes, the app's intelligent algorithms analyzes your profile information and generate a match recommendation for you, considering factors like shared interest, location, and compatibility to suggest a profile with higher chance of being a good fit. These algorithms constantly learn from your interactions, just like a friend who gets better at understanding your preferences over time. And finally, when you find someone you are interested in and then to reciprocate, it's now time to connect. You can then start chatting, getting to know each other better. Now, let's have a look at the technologies behind this. Guys, dating apps use cloud computing to securely store and process vast amount of data. Robust databases like relational or NoSQL are used to store user profiles, preferences, interaction data. Geolocation services are used to identify users' location and suggest matches within a specific range. And when it comes to security, dating apps utilize encryption protocols, secure sockets layer, that is SSL, transport layer security, that is TLS, to secure user communication and protect sensitive data from unauthorized access. Now guys, dating apps use various algorithms to enhance the matching process and increase the probability of finding compatible partners. First is machine learning algorithms. They analyze user behavior, preferences, learn from past matches and feedback to continuously improve suggestions. Then NLP algorithms are used to analyze messages exchanged between the users. VecTech and Word2Vec are the two NLP techniques used in dating apps to calculate the profile similarity and analyze the sentiment. Advanced recommendation systems use collaborative filtering, content-based filtering, or hybrid approaches to suggest potential matches based on users' preference. Image recognition algorithms verifies users' profile picture and detect fake images, helping maintain a safer environment for users. So these were some commonly used algorithms. Now, do you know that which specific algorithm Tinder, Bumble, or Hinge use? Let's see. Guys, there is as such no accurate information present on algorithms used by Tinder or Bumble. But yes, Logan Yuri, Hinge's relationship science director, said that Hinge uses Gale-Shapley algorithm, a Nobel Prize-winning algorithm. So, how does this algorithm work? Let's understand with an example. Let's imagine there are two groups, 5 women and 5 men. The Gale-Shapley algorithm starts with one group. It can be either men or women. Each person of that group starts processing to their first choice. If rejected, they will move on to the second choice and continue until they find someone who accepts their proposal. This process repeats until all the individuals have made proposals or been rejected. Guys, this algorithm ensures that once people are paired up, they won't leave the current partner for someone else who they like more. This stability is achieved by prioritizing each person's preference and ensuring that everyone is paired with their best available match. So now we will start with exploratory data analysis on the dataset consisting of reviews of dating apps from 2013 to 2022 like Tinder, Bumble and Hinge. We will use Jupyter Notebook for this project, so let's jump into that. So guys, here we are basically going to explore the data. We are going to do exploratory data analysis of the data set, that is reviews of dating apps from year 2013 to 2022. So basically it's a 10 year of data, right? This data consists of 10 years of data. So we will have a look at the data after loading the data set. But even before that, we need to install and import some dependencies, right? So yes, let's get started with installing the dependencies. So first we will import NumPy as NP, and we will import pandas as PD. Then for visualization, we will import Seaborn as SNS. We will also import matplotlib dot pyplot as PNP. Then we will import plotly dot express as PX. Then to handle date times, we will import date time as dt from date time. We will import date. Then we will also import regular expressions, handle string data, and yes, we are done with all the installations. Yeah. So yes, we will be installing NumPy, Pandas, Seaborn, Matplotlib and Plotly. These three libraries are basically used for visualization. Then these two date time libraries are for handling date time of data. And then we have regular expressions and matplotlib.inline. Yeah. So now next is we are going to load our data set, right? So to load our data set, we will just do pandas. Pandas means PD read CSV. So I just hope you are all aware of how to import any data set. So guys, we will just go to our data set. We will just copy this and yes, we will paste it here. So yes, we can see our data set is loaded, right? So now we will make a variable for this. Yeah. So df is our data set. Our data set is loaded into this variable, that is df, right? So now we will have a look at our data set, and for that we will use df dot sample. So this is the best method because it will give us some random rows, right? So yes, this is how our data looks like. So we can just have a data at first look, it looks like this, and we can also have a look at the data like df.head. So it will give us the first 5 rows of our data set, right? And similarly, to see last 5 rows, we will just apply df.tail. So guys, this is how we can have a look at our data set, right? Even if you want to increase the number of rows, yes, you can do that. Yeah, even here also you can increase the number of rows, or as per your choice you can do it, right? But by default it gives us 5 rows, right? and this sample data by default gives us just one row. Yeah, so I just hope you are clear with these things, like how we can have a first look at our data set. So yes, every time you will run this df.sample, it will give you different rows, because always these rows are random. So now you can see, like this is the unnamed, in unnamed id you can see it's the id is 471501, but let me run it again. So yeah, now you can see ids are changed, means the rows are changed. Yes, so this is how we can have a look at our data set, right? So just having a first look, we can see there are like, yes, 1 2 3 4 5 6 7 columns are there. Yes, so having a look at this data set, we can see like some of the rows, some of the basically columns are numerical columns, some of the columns are categorical columns, even one of the column, that is date time, it's in date time format. Yeah, so yes, first let's check the shape of this data set, and for that we have a function df.shape. So yes, here is the shape of data set, means there are around 6,81,994 rows. So yes, it's a big data set and there are 7 columns. Fine. So now let's have a look at the general information of the data set. So for that we have a function df.info, which will give us the basic information of this data set. So guys, this df.info will give us the information like all the columns, then non-null columns, then data types of all these columns. Yeah, so seeing at this data set, yes, we can tell there are around integer and integer. Yeah, so we can say out of 7 columns, 3 data types are integers, and object means string data types, or we can say categorical data types. Yeah, so out of 7 columns, 3 are numerical data types, and so yes, we can like mark down here, out of 7 columns, 3 are numerical and 4 are categorical. Yes, so again we can check the data types of all the features. Features means columns. Yeah, so we can check the data types of all the features, and even if it's required, we can change them. So like guys, from here also we can see the data types of all the features, but there is a different function also, so that is d types. Yeah, so using this d types we can check only the data type of all the features, like we don't want to see these null values and all. So one by one we can handle all these things, right? So yes, this is the function for checking data types, and from here we can see again 3 columns are numerical and rest are categorical features. Fine. So guys, from here we can see like this date and time. This date and time feature is also a object type, that is categorical type, but it shouldn't be like this. Yes, so we need to convert this date and time feature into date time. Yeah, so how we can convert one data type into another data type, like using what function or what library we can use here. So yes guys, we can use pandas dot to date time. Yes, so this will convert any column into date time. And what is the column name? Year and date and time. Yes, so guys, this particular function will convert your date time column into date time, from object data type to date time data type. Yes, so we will just assign this, and yeah, just run this particular cell. So yes, now again check the data type. So df dot d types, and yes, this time we can see, yeah, so last time it was in object data type, and yes, this time we can see date time is in date time data type. Fine. So yes, now again we can check the sample of our data, and yes guys, we can see here it's in date time format now. Yes, so first we are having this year, then month, then day. Fine. But earlier the format was something different, so you can like clearly see. So it's converted into date time format. Fine. So now guys, we want to extract date, year, month, week, day, hour from this particular feature. So now as you can see, like month, year, day, hour, minute, all are like in a single form. It's in combined format, like date and time all are in mixed format. But what we want is, we are expecting to have different columns for all these things, like date, year, month, and so yes, we can do that. How we can do that is df and the name of this particular column, that is date and time. Yes. So what we are going to do, we are going to extract the date out of this. So dt, we have already imported this library, right? dt, okay, so it's here, import date time as dt. So this dt is nothing but the date time library. So from dt we are going to extract the date. Fine. And what we are going to do, we are going to make a new column for this. Say, okay, let me just run it and show you. So yes, here is how it looks like. So this was the date, this was the date time column. Yeah. So now I have just extracted this date from this complete column. We have just extracted the date. So yes, the time has gone, only I can see the date now. Fine. So what we can do now is, we can store it in a different column, and we will name this column as date. So yeah, is that fine? We can just, we have to create a new column. That is df and date. So yeah, we have created a different column for this. Now similarly, we can also extract the year out of this complete column. So again, we will do it like df date and time dot dt dot year, right? So let's see. So now yes, we can see that we have extracted only year out of this complete column. Again, what we will do, we will store this in a different column, that is year. Right? So yes. Now similarly, we will do it for month, week, day, hour, etc. Right? So yeah. So yes guys, now we can see that yeah, we have extracted the in this first column. Okay, so it's in sample format. We can get like head. Yeah. So now we can see like the first column, second column, third row. Sorry. So cut and repeat. So say cut and repeat. So now we can see like first row, second row, third row. All these rows are in rows are having which month? That is second month. So here also you can see, yes, we are able to extract only months. But my ask is, like, we want month, but we don't want month in this numerical format. Instead, we want name of the month. So yeah, how we can do that? We can use this function, that is strf time, and for month we can use percent and capital B. So yeah. Now we can see, yes, we are able to extract the name of the month, right? We didn't want the months to be in numerical format. And now again, what we can do is, we can store these in different column, that is month. Fine. And guys, similarly, we can extract the weekdays should be in string format. So yeah, similarly we can extract the weekdays dot bt dot str, and this time we will use person and age. So it will give us, let me just write a comment for you, will give us weekday name, and this particular thing will give us month name. Yeah, so again we are going to store this in a different column, that is weekday. Fine. So yes, we are good to go, we are able to do this. Okay, so I just haven't run this. I'll just copy this and we'll show how does it looks like. So yes guys, we are able to see that we are able to extract all the weekdays. Yeah, fine. So yes, now what we will do, we will extract hours. So bt dot hours. So yes, and again we will store this in a different column, that is here and R. Fine. So yes, what we have done is we have extracted date, we have extracted year, month, weekday, means name of month and name of weekday, and yes, we have also extracted hour from this one column. Fine. So now let's just see like how our data looks like. So yes, we will do df dot sample and 5. So yes guys, can we see like, okay, we have made new columns, that is date, year, month, weekday and hour. So now how many rows and columns we have? So let me just check it. df dot shape. So yes, earlier we were having only 7 columns, but since we have added 5 new columns also, so now we are having 7 plus 5, that is 12 columns in total, but the number of rows are still the same. Fine. So guys, this is how we can add new columns and we can change the data type of any column as and when required. Fine. So next what we will do is we will handle null values. Yes. So yes, what's the function to check the number of null values in our data set? That is df dot is null dot sum, and yeah. So guys, we can see like this unnamed, unnamed 0, that is basically nothing but index, so it's basically of no use for our data set, because by default we are getting indexes for all the rows. So yeah, this column is of no need. If we want, we can even skip this column, this particular column. Yeah. So yes, as of now we can see like how many null values we are having in total for each and every column. We can see here. So this name column is having 5 missing values. Yes, and we can see this review column is having 1, 3, 5, 2 number of missing rows basically. Okay. So as of now we can see just the numbers, but I'm not clear with it. Like I want to see like how many % of my values are missing in total. Fine. So for that what we can do is we can do it like df dot is null, and we can check the mean. It will give us the % of missing values in total. Okay. So let it get multiplied by, okay, so first let's check it like this. So yes, we can see these are the mean, but I want to check it in % format. So yes, so yeah guys, we can see even less than 1% of values are missing. Yeah. So this when we are having in general, when we have like less than 5% of missing values, so in those kind of cases we can drop those values. Yeah. So what we will now do, we can simply ignore them or we can drop them. Yeah. So right here, since missing values are less than 1%, so we will drop them. Fine, we will drop them. So how we can drop missing values? For that we have a function df dot drop na, and in place equals to 2. Why in place equals to 2? To drop them permanently, not temporary, right? So now again we will check this df dot shape. So yeah, we can see earlier what the shape we are having. The number of rows were this much, like at last you can check it's 994, but now as you can see it's only 6, 3 and 7. Fine. So means we have reduced or we have dropped some particular number of rows. Even you can check it like this also, is null dot sum. Yeah. So yes guys, this time you can see like there are no null values remaining because we have handled those null values. And why we have dropped them? Guys, to handle null values even there are like multiple techniques, but here what was happening is the missing values were even less than 1%. Yeah. So 1% doesn't affect our data that much. If we will even drop them, so it won't affect our data that much, right? Even 0.5, even it's less than 0.5, or we can say even it's less than 0.2%. Yeah, so you can think of it like it won't affect our data much, so we can simply drop them. Or if the number of these missing values were like higher, so we could have imputed it using mean or median or mode, depending on our data type, right? Or even it depends on the domain knowledge sometimes. Yeah. So yes, I guess you are now clear with how we can handle missing values. Fine. So next come is handling duplicated data. Fine. So let's check how we can see if our data is duplicated or not, or how many rows are duplicated in our data set. If there will be any, then we can drop them. Yeah. So yes, we can see there is no duplicated data. All the rows, all this much of rows are unique in our data set for all these columns. Fine. So there is no duplicated data. There is no duplicated data. No need to handle them. Guys, it's always a good practice to write the markdown or the observation of whatever you are observing here. So whatever you are observing while writing your code, just write the observations below these cells. Yeah. So whenever next time you will open and you will read this, okay, you will come to know this was the observation for this particular line of code. Fine. So it's always a good practice to write observations, right? So next is what we are having is removing unnecessary features. Yeah. So as I have already told you, like we can just check the columns of our data set using this function. Yeah. That is df.columns. So we are having these columns, these any number of columns. So unnamed, name, review, rating, thumbs up, date and time, app, date, year, month, weekend, hour. So guys, these last 5 columns are the columns we have created just now. Yeah, and these 7 are the columns we were having earlier. So as I've already told you, this unnamed 0, this is a column which is of no use because it shows us the index only. By default, we can also see the index here itself. It's generated by Python, right? So yes, there is no need of this particular column. So we have learned how we can drop rows or how we can drop the null values. So now we will see how we can drop this particular column. So to drop this column, what the code we can write is df dot drop. Yeah. df.drop and the name of this particular column. Okay, so we will just copy this particular column name and yes, we can paste it here. Now what we will do, if we will just simply do like this, then it will throw us an error. Let me show it to you. So yes, yeah, we can see it showing us an error. So yeah, it looks horrible, no? Or like this is just a one line of code and this much big error. So what's there? It says this not found in access. Yeah. So why it's happening like this? If I will keep my cursor here and if I'll press shift plus tab, so it will give us me the description of this particular function drop. So what is by default you can see this axis is 0. Yeah, so guys, axis is 0 means it's considering this particular as row, but we know that this is not a row, this unnamed is a column. So we have to change this axis to 1. Fine, then we will do in place equals to 2. In place equals to 2, as I've already told you, it will drop my column permanently. Yeah, so now run it, and yes, we can see there is no as such error. Yeah, so now let's see df dot sample, or you can also do it using df dot columns to check whether my column is there or not. So just copy this and let me paste it. So yes, now we can see this unnamed column is no more here because we have dropped that column. And in sample also, yes, we can see there is that particular column has been removed permanently. Fine. So yes, this is how we can drop any particular column or unnecessary features or unnecessary columns from our data set. Yeah. So now it's statistical description of numerical data. So there is a famous function for this, that is df dot describe, and guys, it will give us statistical description. Fine. So even if you want to transpose this particular thing, yeah, you can do it. So using this dot and capital T. So fine. So this is how we can see the statistical description. Statistical description means for all the numerical rows. Yeah, for yes, we can also check it for categorical features. Later we will see it, but as of now we can see for like in this particular data set, we can see there are 1, 2, 3 and 4. These 4 are the numerical columns, that is rating, thumbs up, year and hour. So yes, rating, thumbs up, year and hour. So these 4 are the numerical columns we can see. Yes, and the statistical description gives us basically count, mean, standard deviation, minimum value, maximum value. Then we have these 3 quartiles, that is first quartile, second quartile and third quartile. Second quartile basically means the median. Yeah, and this is 25 percentile of data, this is 75 percentile of data. So seeing this data set and seeing the values of this data set, we can just come to know like how many number of values are there. So yes, the number of values will remain same in all the rows because we have already dropped the null values. Fine. So in ratings, guys, we can see the minimum rating given is 0 while the maximum rating given is 5. And we can see the mean is around say 2.9. We can consider this at 3 as well also. Yeah, and 25 percentile means around 25% of the values are less than 1, and around 50% of values are less than 3, and around 75% of the values are less than even 5. Fine. And the maximum value is 5. So yes, and we can also similarly we can check for all the rows, like the minimum thumbs up is 0 and maximum is 5507. Minimum year is 2013 and the maximum is 2022. So we have already seen that our data is from 2013 to 2022. Yeah, and R says minimum is from 0 and max it goes to 23. Yeah, so it's a 24-hour format looks like. Fine. So yes, guys, this is how we can see the statistical description of our data set. Now let's say if we want to check for categorical columns, so how we can do that thing? For that we will write include and yes, oh. So yes, guys, now we can see again we can transpose this particular matrix. Yeah, but I don't think it's necessary. Fine. So okay, let's just do it so that we can compare both these metrics. Yeah? So yes, we can see there are around 6 categorical columns. So out of these 6 categorical columns, in numerical columns, what the information we were getting is count, min, max, mean, standard deviation, 25 percentile, 50 percentile and 75 percentile. While we can see in categorical data, that is name, reviews, app, date. Date is considered inside this object, or we can say this categorical data, fine. And we have then month and weekday. So what we can say is, in categorical columns, you can just use your own logic and you can think of it like, in categorical column, okay, we can do count of all the rows. We can we check like minimum, standard deviation, mean, like these. Can we check these things like median, max, and all these things? Of course not, right? What we can do is we can check for unique values, how many number of unique values we are having in these categorical columns. Yeah. So guys, we can see like app, we are having 3 different kinds of apps, and going further we will see what the 3 different kinds of apps we are having in our complete data set. So yes, we can see the top means most used, most occurring feature, right? Or we can say the frequency. So a Google user, so this is the frequency of for this particular name. Then review is good and the frequency is this much. App is Tinder and the frequency of Tinder is this, that is 525265 something. Yeah. And similarly we can check for all the columns, like we can see month, October is occurring most in our data set and the frequency of that is this. And weekday, which weekday is occurring the most, that is Tuesday. Yeah. And yes, this is the frequency of Tuesday which is occurring inside our data set. Fine. So yes guys, this is how we can check the description or statistical description at using one line of code using this describe function for both numerical and categorical features. Fine. So next thing what we are going to say is value counts. Yeah? So let me just show you what the value count actually means and how does it looks like. So let's apply it on year and dot value counts. Fine. So yes, we can see this value counts basically gives all the unique values of any particular column along with the frequency or the number of times that value is occurring. So guys, inside this year column, we can see we are having this much of years, like 2013 to 2020. Yeah, we can see it's up to 2022. Fine. So we are having these 10 different years or these 10 unique years, and the frequency and it's arranged or it's sorted in frequency wise, like 2019 is occurring most of the times, right? And it's like this much of times, and 2013 occurs only this much times, means around 8,000 times it's occurring inside our data set. So we are having least data for this particular year, and we are having most of the data inside our data set for this particular year. So guys, this is what we are doing, a general exploratory data analysis of our data. We are just having a look at our data set. So basically, how does it looks like? So if someone asks like which year of data is most present inside our data set, so we can use these logics there, right? So yes, now what we are going to do, now we know that we are having, let's just write df.sample here, sample of 5. So yes, we can see like we are having ratings, then thumbs up, then we are having this app, and yes, we are having this month, weekday, hour, all these things. Yeah. So these for all these things, if we want to calculate the frequency of all the unique values inside these columns, these particular columns. So how we can do that? We can there are two options, like we can do separately for all these columns like this, that df, and inside this bracket we can write the name of the column and value count. You can do like that also, but there is an alternate. So why not to apply loops? Yeah. So when we are aware of loops, why can't we apply them? So let's just see how we can apply them, how we can apply the loops now. So first we will make a different variable or different list, and inside this list we will just write all the columns for which we want to calculate the value counts. So we want to calculate the value counts of rating, then just copy and paste it from here itself, and we want to create value counts for thumbs up, then we want value counts for this app, then we want for year, let's say, then we want for month, then for weekday, and lastly we want for hour. Fine. So this is our categorical feature. Yeah. So now what we are going to do, we are going to apply a for loop. So for category in categorical features, fine, what we are looking for, print so fine. Now we can see it looks like so clumsy. So it looks like, okay, this is for ratings, and this is for thumbs up, and this data is for apps. Yeah, so we can see number format we can see now. So these numbers don't gives us like much information of this particular data set, like what are all the unique values in any particular column. So instead what we can do is we can make it in percentage format, right? So how we can do that? We can simply divide this value by df dot shape. And guys, let me show you one more thing. So df dot shape, yeah, so it gives us rows and columns. So what if I just want to extract rows? So yes, this is how we can extract rows. The same logic we are going to apply here also. So df dot shape, and then we want to extract number of rows only, and then we will multiply it by 100. Yeah, so now it looks fine to me, and yes, we can see we are having now things in percentage format. But to make it more like readable, so we can just make it in string format. Name of feature, then new line, and then the values, all the percentage values, and again a new line. And I guess now it will work fine. So that's wrong. Okay. So yeah, now it looks more readable. Like for rating column, we can see one is highly rated, right? So 37% of people have rated 1, then 34% have rated 5, then like around 0% of, or around among out of all this, like approximately 0% have rated 0. So yeah, that's a good thing. Fine. So guys, this is how we can check for all the rows. So we can see for all the apps. Tinder, we have 77% of data is for Tinder we are having. For Bumble we have 15% of data, and for him we are having around 7.7% of data in our this all complete data set. Fine. So for the year we can see, yeah, we have already seen for year, and for month we can see October is most occurring, and yeah, there for months we can see like there is not much difference in months. Yeah, so we can see around all the months are occurring around almost 8%. Yeah, for weekday also we can see like around 14% of data is distributed for all the weekdays. And for hours, we will see, so hours is also, all the hours are uniformly distributed. So just having a look at these value counts, we can tell, okay, this data looks, this particular feature looks uniformly distributed. Yeah, so guys, this is how, just having a look at the data set, we can say, okay, what kind of distribution can be there, or what is the most occurring value, or what is the mode of this particular. Mode means the most occurring or the most frequent value of any data set, yeah, of any column, we can say. Yeah, so this is how we can apply for loop for all these columns. Yeah, so that's all about this value counts, how to use them, how to calculate for all the unique values for any particular column. So now we are going to answer some very interesting questions from this data set using visualization. And guys, for visualization, we will be using three famous libraries of Python, that is matplotlib, seaborn, and plotly. Yeah, so let's get started with question number 1, which says, from year 2013 to year 2022, according to the data set, in which month, okay, in which month are most dating apps used? Okay, according to data set we want to tell. Fine. So yeah, let's do one thing. First we will calculate the value counts of month. So df and month dot value counts. Fine. So yeah, we can see these are the value counts for month. Then what we are going to do is copy this, and we will be finding index. Okay, so yeah, we can see these are the first column states the index, and the second column indicates the values. So these are the index and these are the values of this particular value counts for the feature, that is month. Yeah, so now what we are going to do, we are going to reset the index. So yeah, dot reset index. What it will do is, it will make this first column, that is this one, as index. Fine. So now this is our index and this is our month. So now next what we are going to do is, we will be creating a plot to check this, to see the answer of this particular question, that in which month most of the dating apps are used. Yeah. So guys, for this we will be using a bar chart or bar graph, we can say. So yes, let's do that. First we will create a variable saying month counts, and inside this month counts we will just save this df month and value count for this particular. Yeah. So now what we are going to do is plt dot figure, and we can specify the figure size here. Then we will be using bar chart for from this matplotlib library. PLT means matplotlib, which we have already imported, right? So let's just see the description for this particular. First we want to insert x, height or weight and whatever. So first let's insert or give argument as x. So what will be my x? That is so guys, we have already seen, like, this was the value counts for particular month. Yeah, so this was the index, and this we want as our x, and in value in y column what we want is the values for this particular. Yeah, so we have made a variable for this value counts. Now what we want is the index and values of this month count, right? So in x column what we want is, we want month counts dot index. Yeah, and in y column what we want is month counts dot values. Yeah, so I guess you are good till here. means this is the x-axis, these are the values of x-axis, and these are the values of y-axis. Fine. Then what the width we want is, even it will not give this width, it's okay, it's fine. We can yes give it. It will be 0.6. Okay. So now what we can do, we can give x label, y label and title for this particular graph. So x label, it will be say month, y label, it will be the frequency, and in title we can say frequency of categories in month. Fine. So plt dot title, here we can see frequency of categories in month. Yeah. So now what we can do is we can change the layout, and these are guys, these are the optional things. If you want, you can add these things or add these lines of code, otherwise you can just leave it. And at last what we will do is plt dot show, so it will not show us the extra text and all, it will just show us the direct graph or diagram, we can say. Yeah. So yeah, now you can see in x-axis we are not able to read these months properly because these months name look quite large. So for that what we can do is we can add x-sticks, plt dot x-sticks. Fine. And inside this we can make a rotation of 45 degree, and this J will be right, orientation will be right side. So yeah, now we can see we are able to read all the x-axis labels properly and y-axis labels properly, and this is the title of our what we can say is bar chart. Yeah. So guys, from seeing this graph, seeing this plot, what we can say is from 2013 to 2022, which month are in which month most of the dating apps are used, right? So guys, this bar graph gives us the in sorted form we can get this, because this value counts gives us the result in sorted form only, right? And we have used that only, right? We have used the index and counts for this value counts only. Fine. So yes, we can see in October month most of the dating apps are used. So this is the simple answer we can give. So answer will be October. Fine. So yeah, in October month most of the dating apps are used. Fine. So yes, this is all about the first question. Now yes, one more thing is, you can just drag and drop it to another tab and you can see this graph very clearly if you want to see it in another tab. Yeah. So now we can see this graph very clearly. Even if you want to save it, so you can save this as image. Yeah. So yes guys, this is how we can create graph using matplotlib. Now moving on to the second question, which says from year 2013 to 2022, according to the data set, in which year? So first question was asking for month, in which month? So answer was October. So now it's asking us for year, in which year most of the dating apps are used, okay, or most of the dating apps were used. So yes, let's find out. So guys, for this basically we are going to use a library that is Plotly. Yeah. So just let's see what's the speciality of this particular library. So yeah, what we will do is we will create a variable for year counts, and here what we are going to do is df year and value counts. Okay, So value counts, and we are going to this time reset the index. I've already shown you in last example that after doing reset index what we get, right? Just the reset is just the index is resetted, right? So now we will give fig is equals to px. Why px? Because we have imported this plotly.express as px only. So for px we will be using a bar graph for this px, and yes, we will give this particular data frame. Why what? Let me just show you what this particular thing will give us. Just copy and paste, and yes, so basically this is nothing but it looks like a data frame only. Yeah, so let me just go and show you the description for this px.bar graph. It asks for a data frame first, then x-axis and y-axis. Yeah, so that's what we are going to do. We are going to pass the what we are going to pass. We are going to pass the data frame, and here is the data frame. So we have just assigned this complete data frame inside this year counts. Yeah, so that's why we are using year counts here, right? And in x, as x-axis, what we are going to do, we are so this in x-axis we are going to have this index, and in y-axis we are going to use this year. So in x, what we are going to do, we are going to use index, and in y-axis what we are going to do, we are going to use this year. Fine. So I just hope it's clear till now. Now in labels, so in labels, because in plotly we can see the labels as well. So in labels what we want is, we want index, and in index what we want is, basically index is nothing but the year itself. Yeah, so year, and in here what we want is frequency. So yes, now we can just plot it using or we can just first update this shape and size and the layout. Yeah, so we can just this is again an optional thing, but if you really want, you can just create a new layout, or you can just update the layout for this particular graph. So how we are going to do that? We are going to just make a title for this, that is frequency of categories in year. Yeah? So frequency of categories in year. Fine. So frequency of categories in year, then we are going to do guys, again I'm repeating, these are kind of the optional things. If you want, you can skip these things. Yeah, these are just to make the graph more clearer and more readable in readable format. Yeah, so you can also skip this particular thing, like updating this layouts and all these things. So these are nothing but specifying the width and height of the particular graph, because by default the graph comes out to be very large. Yeah, so if you are okay with that, it's okay, you can just skip this particular thing. And at last what we are going to do, figure dot show. So let me run this, and yes, now we can see. So in previous graph we can see, like when I'm hovering over here, so I cannot see anything, right? But what's the speciality of this plotly graph? When I will hover over this, so what I can see is the labels. So labels is, these are the labels which we have created. The first is index, in which we can see year, and the second is year, in which we are seeing the frequency. So the first is year and the second is nothing but the frequency. Yeah, so inside this first one, that is year, so here we can see, okay, the first one is year, and in year what we are getting is index. So index is nothing but these years only. And the second is frequency. So yes, here we can see the second label is frequency, and inside this frequency what we can see is the years. So these are the counts of years. Yeah. So now next thing is title. So guys, here you can see here is the title, frequency of categories in year. Fine. And what we have done is, this is x-axis, tick angle minus 45 degrees. So these are nothing but the orientation of these x-axis labels, and again this is year and frequency. These are the x and y labels you can see. Fine. So yes, this is kind of how we can draw a plotly chart. So these are kind of more interactive. Whenever we'll hover, we can see the exact values. Like in year 21, the frequency was 95k, around it was 95k, and so we can see clearly. So yeah, in year 2019 most of the apps were used. So what was our question? Our question was, in which year are the most dating apps used? So yes, now we are able to answer this particular question. Yeah. So yes, we can say in year 2019, in year 2019 most of the apps were used. Yeah. So are we good to go ahead? Yeah, one more thing I would like to tell here, that in Plotly you can just select any piece of plot and you can visualize that particular. So let's say if I want from year 2013, 14 and 15, I just want to see the plot of this particular thing also. I can just drag in, I can just select this particular portion, and yeah, it will show me for year 2013, 14 and 15 only. Yeah. So I will just run this particular cell again so that it can show me the complete chart. So likewise, you can just select any particular portion and you can visualize that particular portion. So guys, this is the functionality given inside Plotly. So this is one of the reason, like now these days mostly this particular chart is being used. Yeah, because of its interactivity. Yeah. So yes, from here you can like zoom in, zoom out, and yeah, you can like zoom in, zoom out, you can do multiple things. So fine, this looks fine to me. So yeah, so now we can move on to the next question, and which says, from year 2013 to 2022, according to the data set, in which month and year? So first question was for month, the answer was October. The second question was for year, and the answer was 2019. Now why we are finding for month and year in combined format? So yes, after seeing the plot you will come to know that why I made this as a separate question. Yeah. So yes, so now here we are going to use group by function. So df dot group by. Fine. And on what column we want to do group by? On date column we want to do group by, and basically what we are looking for, we are looking for the count of dates. So date dot count, this is something we are looking for. Now let's just see the result. So yeah, so we can see for all the different dates we are having these counts. Fine. So for all the different dates we are having these particular counts. Fine. So yeah, we will just save this particular frame inside data, inside the variable that is data and groups. Data groups. So yeah, fine. Now just copy this and paste it, and yes, we can see this is the data groups. Fine. So now what we are going to do, so these are the different dates. Yeah. So first we were seeing for alone month. Now in second question we have seen for alone years. Now we are seeing for all the dates. Like on this particular date, we can see there are 32 records, or 32 might be 32 people have used this particular app. Yeah. So we want to see in which month and year. So basically what we are going to see on which dates, or on which month and date, month and year in combined format the dating apps were most used. Yeah. So again we are going to use Plotly, and this time we are going to use px.line, means line chart of this Plotly graph. and yes, we are going to pass this date groups as a data frame. Yeah, so this time we don't want to give x-axis and y-axis, because yeah, it's clear from this data frame itself that okay, this is x and this is y. So this time we are going to plot a line chart, and I'm just skipping all the rest of extra things like we have done here, title and all this. If you want, you can just yeah, you can use them as per your requirement. So yes guys, here we can see this is the complete graph for year and month. So when I'm hovering over here, hovering over any value, I can see three labels this time. The first one is variable, that is equals to date, and second one is index, and the third one is value, which shows me the count of all these things. So now as we can see, we are not able to see this. We can clearly see that okay, so this is so yes, we can see November 16. In November 16, it looks like most of the dating apps were used. Fine. And yes, we can see okay, this is Feb 22. So there was a sudden fall in Feb 22 in the use of dating apps. So these are the two observations, these are the two main observations we can find from this particular line chart. So let me just select this particular portion, and yeah, let me just see. Okay, so fine, in October 16, in between October 16 and Jan 17, it looks like okay, this is the November year we are talking about. Yeah. So let's just run this particular line of code again to see the complete chart. Yeah. Okay. So yes, we can see it's November 16, and the date also looks like 15 November. So on 15 November 2016, most of the dating apps were used. Yeah. And now again run this cell, and we will this time check for falling. Yeah, so we'll select this particular portion, and yes, we can see in Feb 22 there was a sudden fall. There was a sudden fall in the use of dating apps. So yes, what observations we have made is in November 2016, most of the dating apps were used. This is the first observation we can say. And the second observation is there was a sudden fall in use of dating apps. Yeah. So there was a sudden fall in the use of dating apps in Feb and 2022. Yeah. So yes, these are some of the analysis we have done using this particular data set. Yes. So yeah, moving on to the next question, that is question number 4, which says, from ratings 1 to 5, which rating is most frequently done? Yeah. So yes, again it looks like that we want to use count. So this time again we will be using value counts rating, and this is the value counts. So guys, just seeing this, we can say okay, so rating 1 is given most frequently given, and rating 0 is least frequently, or it's given just by one single person, or there is a one single record found where we have rating as 0. So yeah, seeing this also we can say that okay, we can answer this particular question that rating 1 is given is done by most of the persons. But what if I ask you to do this same thing using a plot, or I want to see this particular thing using a plot? Yeah. So what do you think, which will be the best plot for this? So let's do it using bar plot again. So yes, we will again make a variable for rating counts, variable as rating counts for df, and yeah, so I to repeat again, just let's copy and paste this particular thing, and we will do reset index. So reset index, fine. Then next what we are going to do, we are again going to follow the same procedure to create a bar chart using plotly. we are going to pass the data frame first, then we are going to pass the x-axis. Okay, in x-axis we are going to pass index, and in y-axis what we are going to pass, we are going to pass the rating. So let me first show you this particular thing. Okay, how does it looks like? So yeah, this is how it looks like. So this index is we are going to keep it as x, and this rating is we are going to keep it as y. So yeah, and again in labels what we want to see is, in labels what we want is we want this index. Okay, so I have to keep it in string format, index as rating, and the next thing we want this rating means this second column as, I want to name it as the frequency. Yeah, so let's say frequency. And again for updating, I'm not going to write this code again and again, so let me just copy this particular code for updating the layouts and all those things. And yes, we can do it. Figure update layout, and this time I'll write figure frequency of categories in rating, not here. So because this time we are going to find for ratings. Yeah, and I will just write fig dot show. It will show me the plotly bar graph. So yes guys, from here we can clearly see like rating 1 is most frequently done, followed by rating number 5, then 4, then 3, then 2, and at last we can see it's 0. Yeah, so this is the insight we are getting from this particular graph. So yes, we can see rating 1 is most frequently done, while 0 is least done. Fine. So this is the insight we can get from this particular graph. So yeah, moving on to the next question, that is question number 5. It says from rating 1 to 5, which apps, this time which apps has got more 5-star ratings. Yeah, so this time we are going to check for apps, that which app has got most 5-star ratings. So guys, this time what we are going to use, we are going to use a Seaborn library. Yeah, so we have seen how to use Plotly, how to use Matplotlib. So this time we are going to use Seaborn library to create count plots. Yeah, so let me just write the code for you. So plt.figure, and inside this we are giving our figure size. So figure size, let me give it 8 of 4, and yes, so let me just define ax is equals to sns dot count plot. Okay, inside this count plot, so let's first see the description of this particular Seaborn count plot. So yes, it asks for data x, y, u, and all. U means the differentiating on base of color. Yeah, so let me give data is equals to df. Yeah, and x we want as app. Fine. Then we want to make the colors based on, or we want to differentiate on the basis of colors. Let's say rating. Yeah, so yes, this is the Seaborn. Now okay, so we can label it, and plt dot x label. On x-axis we can write applications, or we can write apps. Then on y label, that is, we can write frequency. Then we can give the title as frequency of categories in apps. Fine. And we can also define the legends. Legends means, we'll just show you what are legends. So legends, I just want my title as rating. So basically legends are nothing but the colors, which color defines what. Yeah, so now TLT dot, again this is an optional thing, this tight layout and these layout updates, you can do it as if you require these things. At last we'll just do it TLT dot show. So now let's just run this and check it out. Okay, so we are having some issue with this. Okay, so it's not legends, it's just legend. Fine. So yes, this time we can see we have removed the error, and yes, we can see like, okay, let me just show you. First I was talking about these legends, so these are the legends. Yeah, so just let me cut this, and now let's run this. Okay, so now we can see what was our question. Our question was, from ratings 1 to 5, which app has got 5-star ratings? Yeah, so let's say first let's just count for these particular apps only. Just forget about the ratings. Yeah, so what are the counts for all these apps? So yes, we can see Tinder is most used, then followed by Bumble, and then Hinge. Yeah, so 77% we have already seen using that account. Yeah, again, if you want, I can just show you. So df and app dot value and counts. So yes, we can see, and even if we want, we can convert it to percent format, that is df dot shape and 0. So yeah, it's again not in percent format, multiplied by 100. So yes guys, we can see around 77% is covered by Tinder, then Bumble, and then Hinge. This is what we can see here. But our question was, we just wanted to find out that which app has got 5-star ratings. So what we want to do, we want to we just want to make it, yeah, so what we want to do, we just want to break these apps based on the ratings. So that is the reason we are using you, means based on colors. So colors will be differentiated on basis of this rating feature. Yeah, so let me just run this, and yes, now we can see. So this orange line, what this orange line denotes as one star rating. Yeah, so what we want to figure out, that which apps are given 5-star ratings, more 5-star ratings. So let's just see. 5-star rating means this brown color. So which app is given most 5-star ratings? So obviously this Tinder app. Yeah, this Tinder app is given more 5-star ratings. So guys, we can see for Hinge app, it looks like 5-star rating is even more given than this 1-star rating, while in Bumble and Tinder 1-star rating is most frequent or most given. Yeah, so yes, one conclusion we can make from here, if we okay, overall if we want to answer this question, that which app has got 5-star ratings, more 5-star ratings, so yes, of course this Tinder has got more 5-star ratings, because we can just compare these brown colors bars, right? But when but just remove this you and observe one thing, because we have more data present for this Tinder app only, so it's quite obvious that this app only will get all the ratings more than as compared to Bumble and Hinge. But yes, if we compare the things based on ratio wise, if we consider the things like which app has got more 5-star ratings even than 1, 2, 3 or 4, so yes, that is Hinge app. So there can be two answers for this question. If overall we are seeing, so yes, Tinder app has got more 5-star ratings, but if ratio wise we are seeing, so yes, Hinge has got more 5-star ratings as compared to or ratio wise we can see. Yeah, So yes, this was about this question number 5. So our next question is what is the market share of each app? Yes, so yeah, let's see. PLT dot figure, and again the figure size, let's keep it let's say 6,4. yeah, you can adjust it as you require these things. So again we are going to use Plotly for this, for creating. So now guys, since we know that there are three types of apps in our data set, so what do you think, which kind of graph will suit? Obviously pie chart we can plot for seeing the market share of each app. Yeah, so again if we want to see the description for this, then we can press shift plus tab, and yes, we can see that it wants data, then it's looking for values, names, and all those things. Yeah, so we are giving df as our data frame, then we are giving our values as df and app, and yes, we can even save it, or we can even assign a different variable for doing this particular thing, but it's fine, let's do it here itself, counts. And we have, since we have already seen how to make values and indexes for all these things. Yeah, so yes, then we can give names will be df and app, again the value counts, and this time index has names, and in values what we can save as values for we have already seen these things guys, right? So yeah, comma, and this time we can put the title as percentage of dating apps used between Feb 2013. So because guys, our data is from Feb 2013 to December 2022. So yes, and the last thing we are going to write is figure dot show. Yeah, so yes, it will show us the market share of each app. So yes, we can see Tinder is most used. Yeah, so yes, we can write in answer, Tinder is having around 77.2% of market share, having 77.2% of market share. So yes, so guys, question number 7 is what is the market share of each application, or we can say app, over the years? Yeah, so guys, this is a code for calculating this particular thing, market share over years, if you want to find for all the 3 different apps. Yeah, so yes, we can do it using a line chart. So this is how we can calculate total apps. So guys, this is the code to calculate like total apps we can calculate using this group by operation, which we have already seen too many times. And then we can also find the market share. So in market share, basically what we are going to do, we are going to calculate, or we are going to make a different feature or different column for this particular data set, that is df itself. And in this, what we are going to do, we are going to apply group by first on the year, and then we are going to apply the same thing on the app, right? And we are going to count for all those things. And then why we are dividing with total apps? Because we want to find the percent of market share. So to calculate percent, we have multiplied this complete thing by 100. So let me just run this particular cell, and yes, this is the code for creating a line chart, which we have again already seen. So this is nothing but the title, X label, Y label, legend, and show. So the main thing is this. Also, we have seen this PLT dot figure, which we are giving figure size basically. So these are the 2 new lines. The first one is line colors. So basically, we are having 3 different apps. So we are just defining 3 different colors for all those apps. Yeah. And the next thing is what is this for loop now? So what is this for loop? Basically we are using zip function here. So app comma color in this complete zip function. So in this zip function what we'll get a different app, and we will get the color for that particular app, which we have defined inside this line colors. Yeah. So yes, then what we are going to do, nothing but we are going to plot this. Okay. So yes, let's just run this and check it out what our result is. What does this particular graph tells us? So yes, we can see this green line basically shows Tinder. Yeah. So and this yellow line shows for the Bumble, and this purple line is for Hinge. Yeah. So what we can say is, we can see Tinder for years 2013, 14 and 15 the market share was like constant. Then in 16 it fall down, and 17, then 18, 19, 20, then in 21 it raised. Yeah. And in 22 again it fall down. While in Bumble and Hinge, what happens is Bumble looks like okay, it's continuously, the market share of Bumble is continuously increasing. And for Hinge, what we can see, first it increased, then it became quite constant, or we can say approximately market share was equal to Bumble only. Then, but again, in year 21 and 22, it fall down. So guys, this kind of analysis we can do, like it's a very important term, that is my market share. So we can just press it in different tab and we can check it out. Yeah. So the market share of Tinder looks like it's going down year by year, while Bumble is performing well. We can conclude from here, kind of thing. So yes, this was about the market share of 3 different apps, that is Tinder, Bumble and Hinge, over different years from 2013 to 2022. So yes, and the last question we are having is, do people find relationship on dating apps? So we have studied a lot about dating apps. We have seen the market share over months, over years, and many things we have seen, and many questions we have answered. So the last thing comes is, do people actually find relationships on dating apps? So yes, we are going to figure it out, and for this we will be using 2 features basically. So let me just create a sample of data for you. So yes, we are having these many columns: name, review, rating. So what do you think, how using which features basically we can find these things, that people actually find relationships or not? So obviously based on their final ratings and reviews only we can tell, okay, a person is able to find a relationship or not. Like if the reviews are good and the ratings are good as well, so we can say okay, fine, so the people are able to find their partners or their any companions on these dating apps. So let me just run it and just go through these reviews once. Yeah. So let me just make a different feature for this. Yeah. So yes, we can see like on this app I can't find a partner, Tinder would be so much better, and yes, we can see like these of things. Yeah. So this is incredible, quality of dating app, I can't get past, and these many reviews are there. Yeah. So the app not working, it's useless, kind of reviews are there. Okay. So yes guys, and the ratings are also given by people. Yeah. So yeah, so now let's see how we can find that people are able to find the relationships or not. So yes, continue. So guys, first we are going to create a function for found. Okay, so we will just see what kind of messages can be there. So we are going to pass review inside this function and we can match. So we have imported the regex library, that is regular expressions library, and here we are going to use that library to find a match. Yeah. So yes, we can do it. So what do you think, what kind of messages can be there, like if someone has found or not found their partners? So it can be like met or found, and there can be any text. Let's say we are keeping a size of 0 to 20. Yeah, and yes, it can be like found husband, okay, or one can found wife or met his wife, okay. Then what else we can have is found a partner, or we can the review can be like found a love, okay, anything it can be, fine. And the review, and here we will have flags. So I will just explain this code. So it says if match. So guys, what this thing is going to do basically, it will return, this match variable will return either true or it will return either false. So match dot group and 0, fine. So let me just show you what does it returns basically. Let's just run this function first, and now what we are going to do, inside this found we are going to pass a statement. Let's say I reviewed, like I met my partner, okay. So let's say, okay, so what it will return, met my partner, fine. So it will cut all the rest of extra things, it will cut like met my partner, he is really good person, kind of reviews we can give, yeah. But what this found function will return, it will return only from met to these things, anything it can be, like husband, wife, partner, love, anything it can be, fine. And inside between these two keywords like met or found and husband or wife or partner or love, between these things there can be from 0 to 20 words, right? So yeah, I met my partner, and it shows like this, fine. Now let's just copy this function, paste it, and let me show one more code to you, that is of not found. So here also I will write not found, yeah. So this time what will happen is, here I will just write not met or found, fine. So if it says if not match, here I will assign it as not a match, and it will group it accordingly, not a match. And yes, again this time let me just run this function, and we are calling not found, and we are passing I did not found a match, yeah. So let's say, so what it's saying is not met, not found, fine. So not found, so basically there are no other words inside it, so that's why it's giving just not and found. So guys, I hope you have just understood these two functions, like how this found and not found function works, yeah. So now what we are going to do basically, we are going to make a different column by the name of found relation, yeah. So let me show you one more thing. In found, if I say I did not met my partner, yeah. So guys, this is the thing here, I did not met my partner is also giving output as met my partner, which is definitely a false thing, and that is the reason along with reviews we are going to also use the ratings, because if a person has found his or her partner, then definitely he is going to give more ratings, yeah. And if he or she is not going to find a partner, then they are going to give less ratings. So yes, that's the drawback of this particular function, and for that we will be using ratings also. So as of now, let me just remove this. I met my partner is okay. Yeah. So let's make a different feature now which says dear, and inside which we are passing the review. Yeah. And it will fill any with nothing, or blank strings. And here guys, we are going to apply this function. Which function? Found function, which we have made right now. So we are going to use this particular function. Yeah. And we are going to like, if I'll give input as this particular review, if I'm going to give as input, so yes, it's going to give me this as my output. Yeah. So yes, we are going to make a different feature for this, that is found relation. Yeah. So let's just run this, and let me print this column for you, and let's see what happens. So yes guys, we can see it's none, but okay, so let's just see the value counts. Might be it can show us the different values. Yeah. So value counts, and yeah, so yeah, we can see met the love, found the love, met the love, met my wife, found the love. So guys, there are like most of the most frequent thing what is happening is met the love. But as I've already shown you, it can be even if I'll write here I didn't met my partner or I didn't met my love, it will also give us this met my love or met the love. Yeah. So for that reason, we will be using one more thing, that is rating. Yeah. So let's just have a look at this particular thing first. Say dear. So what we are going to do, we are going to fetch only those rows in which we are having this found relation column as not null. Yeah. And dot sample. So yes, we can see met the love, met my wife, etc. Fine. So even we can work more on this, like met the love. These two are the same things. So here we can see these are the two same things, but just because of the difference in capital letter or small letter, we are getting these as two different lines or two different statements. Yeah. So we can even work more on that, but as of now we are not working on the text data. Instead, what we are doing, we are working on match. We are going to see if there is a match or not. Yeah. So now again, what we are going to do is we are going to find those particular rows or those records in which the rating is. As I've already told you, we are also going to work with ratings also, where the rating is even like greater than or equal to 4. So if someone has really met or really loved this app, so they will rate it like more than 4. That can be 4 or 5. Yeah. So what we are going to do finally, we are going to mix both these things, and what we are going to do is we are going to apply a end condition here. What end condition? So the first is this one, that is it should be not null. Okay. So here we can apply this thing. And condition we are going to apply, and we are going to see it should be, the rating should be greater than or equal to 4. Yeah. So after combining both these things only, we can say okay, so the person has finally met his love, his or her love, and they are satisfied with the app. So these are quite some of the records where we can see okay, the person has found or actually not found. So yeah, now finally what we are going to do, we are going to create a pie chart for this particular thing. So guys, this is basically the function, or we are going to plot a pie chart. We have already created so many pie charts. So here we are going to use matplotlib library to create a pie chart. And what we are going to do, again, we are going to set the colors for both the things. And here we are going to give a data frame as this found relation. Basically this is a feature, and the labels will be didn't find and found the relationship. So guys, yes, we can see only around 0.26% of the people are able to find the relationship on dating apps, while 99.74% are not able to find, according to our analysis and according to the data set that is being given. Yeah, so we are having the data for 10 years, and we are having the data for 3 different apps, that is Tinder, Bumble and Hinge. Yeah, so guys, we have analyzed the data. We have done the exploratory data analysis, statistical analysis. We have handled null values, duplicates, statistical analysis. We have seen value counts, and we have answered different questions based on this data, right? So I just hope you are now aware of how we can do an exploratory data analysis on any this kind of data set, any such kind of data set, and how we can visualize the things. Yeah, how we can visualize the things based on different factors and using different libraries. So I just hope you have all enjoyed this particular session on data science for dating apps. So guys, I just hope you have all enjoyed this particular session. So subscribe to Fingertips, and do let us know in the comment section that on which topic you want the next video. Thank you for watching, and happy learning.